Hey, welcome to The Explainer. So today we are prying open the computer's cookbook. We're going to look right past the shiny screens and all the icons to really understand the secret recipes that make our entire digital world work. Have you ever stopped to wonder how your phone can instantly find that one photo of your dog from 3 summers ago? Or how it shuffles a playlist with thousands of songs and doesn't miss a single beat? You'd think it's magic, right? But it's really not. Well, the answer is something called an algorithm. And look, they sound way more complicated than they actually are. At its heart, an algorithm is just a recipe. That's it. It's a simple, step-by-step set of instructions that tells the computer exactly what to do to solve one specific problem. All right, so here's our game plan for this explainer. We're going to start with the absolute basics, tallying and counting. Then we'll move on to finding the best and worst, go on a hunt for data, and finally, learn how to bring order out of complete chaos. By the end, you're going to have your very own algorithm toolkit. Okay, so you know how every great chef has to learn the basics first, like how to measure ingredients? Well, for a computer, that basic skill is tallying and counting. These are the absolute fundamental building blocks in its cookbook. So let's try a little thought experiment. Picture this. You're a teacher, and you've got a stack of 30 tests you just graded. How do you figure out the total score for the entire class? The thing is, you already know how to do this without even thinking about it, and a computer follows pretty much the exact same logic. Okay, so this right here, this is basically our recipe card. It's written in something called pseudocode, which is just a simplified way to write out instructions for a computer. Now don't get hung up on all the text. We're just going to focus on that first recipe at the top for tallying, and we'll break it down step by step. All right, step 1, total equals 0. This is literally just telling the computer, hey, create a placeholder for our final number and make sure it starts at 0. Think about it like this. You're grabbing a big, empty mixing bowl before you start adding your ingredients. You always got to start with a clean slate. Okay, next up, the recipe says for counter 1 to class size. This is what we call a loop. It's basically the computer's way of saying, all right, for every single test in this pile, from the very first one to the very last one, I need you to do the following action. It's just a way to make sure we don't miss a single one.
And this is the part that actually does the work. Total equals total plus student mark. For each test paper, it grabs the student's score and adds it to the total that we're keeping. Just like you're adding 1 scoop of flour to the bowl, then another, until you're done. And that's it. That's tallying.
And believe it or not, this super simple recipe is, well, it's everywhere. When your online shopping cart calculates your final bill, it's using a tallying algorithm. And a slightly different version, just counting by 1, is what powers all those like and view counts you see on social media every single day.
Okay, so we know computers can add stuff up. But what about making a judgment call? Like, how do they find the best score or the lowest price? For that, the computer needs a new recipe. One that's all about making comparisons.
Now, I know this recipe looks a little busier, but the idea behind it is pretty much the same. It still uses a loop to go through every single item on the list. But instead of just adding them up, it's constantly asking questions like, hey, is this new score higher than the highest one I've seen so far? Or is this one lower than the lowest?
And here's something really cool. There's actually more than one way to get this recipe started. You could be a pessimist and set your starting maximum mark to 0. That way, literally the first real score you look at is guaranteed to be higher. Or you could be a realist and just grab the very first score from the list and say, okay, this is the champion, for now. Both methods get you to the exact same answer in the end.
All right, so we can find the top and the bottom of a list. But what if we're not looking for an extreme? What if we're looking for one specific thing in a giant list? A real needle in a haystack? Well, now we're on a hunt for data, and our recipe for that is called a linear search.
The logic here is about as simple as it gets. It's like looking for someone's name in a contact list by starting at A and just checking every single entry one by one. This recipe card shows exactly how a computer pulls that off. Let's break it down.
So the search kicks off by setting something called a flag. Just imagine you have a little sticky note that asks, found it yet? And you start with the answer, nope. That's what found false is doing. We just assume we haven't found what we're looking for until we actually, find it.
And here is the really smart part of this recipe. The loop is set up to stop as soon as one of two things happens. Either we find what we're looking for, or we run out of names on the list. I mean, why would you waste energy checking the rest of the list if you've already found what you came for? It's really simple, but it's also incredibly efficient.
All right, and now for what I think is the grand finale of our recipe book, sorting. How does a computer take a completely jumbled, chaotic mess of numbers or names and turn it into something perfectly ordered? Well, one of the most classic ways is with a recipe called bubble sort.
So before we dig into the official description, let's just think about the logic. It's kind of like a simple little dance. The computer looks at the first two items in a list. If they're in the wrong order, it swaps them. Then it shuffles over to the next pair, the second and third items, and does the same thing. It just keeps doing this all the way down to the end of the list. And that's called one full pass.
And that's why they call it bubble sort. With every pass, the biggest, out-of-place numbers bubble up towards the end of the list, right where they belong. So how does the computer know when it's all done? Easy. It just keeps making these passes over and over again until it can do one complete pass without making a single swap. That's the signal that everything is finally perfectly in order.
All right, so let's do a quick recap. Let's take a look at all the awesome, powerful recipes we've just added to our digital cookbook today. These are the tools that build our digital world.
We've got tallying for getting that running total. We've got counting just to see how many of something there are. We learned how to find the maximum and minimum values in a messy list, how to use a linear search to hunt down one specific item, and finally, how to use bubble sort to create perfect order out of chaos. These 5 logical patterns, they're the building blocks for so much of the software we use every day.
And that really is the key takeaway here. Algorithms, they're not some kind of digital magic. They're just recipes. They're logical steps for solving a problem. So the next time you're facing some messy task, whether it's organizing your bookshelf or planning a road trip, I want you to stop for a second and just ask yourself, what would the recipe for this look like? When you do that, you're already thinking like a computer scientist.